So this kind of question, you want to know which compounds or substance are soluble and which are insoluble, because you are filtering, right, the underlying substance. So calcium carbonate is insoluble, and I'll talk to you about solubility rule in a bit. And then sodium chloride is soluble, copper sulfate is soluble, sodium chloride is soluble, so you cannot separate two soluble substances by filtering. So B is not the answer. Ethanoic acid is soluble as well, and ethanol is soluble, so you cannot separate two liquids or two solutions using filtering. Iron and magnesium are both solid, all right, so you also cannot separate those. So how do we know that something is soluble or insoluble? We have to know the solubility rule. So what this solubility rule is saying is that nitrates, acetates, group 1, and ammonium are always soluble, no exception. Now, sulfates have some exceptions. Most sulfates are soluble, but there are exceptions. You go to the second column here, you have PMS, which stands for lead, mercury, and silver, and Castro-Bear, calcium, strontium, and barium. So if you have barium sulfate, let's say, you will know that this barium sulfate is insoluble. Why? Because sulfate and barium is insoluble. But if I say copper sulfate, now copper is not an exception, so copper sulfate must be soluble. Another one is group 7. So you have fluoride, chloride, bromide. These are always soluble except for 1 star. 1 star is PMS. So lead, mercury, silver halides are insoluble. And you also have to memorize that most hydroxides, carbonates are insoluble. There are exceptions, but most of them are insoluble. So one of the exceptions for this is group 1, because group 1 compounds are always soluble. So sodium hydroxide, sodium carbonate are soluble. Which method is most suitable to obtain zinc carbonate from a suspension of zinc carbonate and water? So the word suspension means it involves solid. Okay, zinc carbonate is insoluble, so you just filter it. When you are doing the paper, don't hesitate to tick, cross, underline, write notes, because it helps you focus. Okay, next, we want to investigate how the concentration of an acid affect the speed of reaction, and then we have to measure the mass and also the temperature. Now we also have to measure an amount of acid. So what do we use? Definitely balance, because we need 0.5 gram thermometer. And also, if we want to measure the speed of reaction, we need a clock or stopwatch. And to measure an amount of acid, we need a measuring cylinder. Okay, I wanted to talk to you about these 3 measuring apparatus. So the first one is measuring cylinder. This is the lowest accuracy. The second one is called pipette, and the other one is burette. Now both of these are very accurate, but the difference is this, guys. Pipette only can measure one volume, one fixed volume. Like there is this line on the pipette. It tells you where the level should be. Okay, let's say this pipette is 25.0 cm cube. Then you have to fill it up to this line You cannot measure 20.0 cm cube using this pipette. Okay, one pipette only measures to one volume. Burette, however, you can measure any volume you want. Burette is written to one decimal place for IGCSE, so that shows you how high the accuracy is. So how do you know when you are asked, let's say for example, a student measures 25 cm cube of solution. How do you know which apparatus to use? If there is no decimal place written, you don't need a high accuracy. You can use measuring cylinder. But if they ask you to measure 25.0 cm cube, so if there is one decimal place, you have to use a more accurate apparatus. So you can go with pipette or burette. If they ask you to measure 12.5 cm cube, all right, there is one decimal place, so needs to be accurate, and the volume is not that fixed volume of pipette. There is no 12.5 cm cube of pipette, so you need a burette for this. All right, next one is chromatography. They may ask you to calculate the RF value of a sample. Okay, so let's say calculate the RF value of this dot here. So you take your ruler and then measure the distance of the middle of this point to the origin. Let's call this A. Divide that with the solvent front to the origin. Okay, let's label this B. So RF value equals A divided by B. Next is if you want to separate a solid from a liquid or a solution, then you use filtration. And the solid that is caught in the filter paper is called residue, whereas the liquid or the solution is called filtrate. There are two types of distillation. One is simple distillation, this is simple, and one is fractional distillation. So the difference is simple distillation is to separate the solvent from soluble solid. For example, you have sodium chloride solution, right? Sodium chloride at normal condition, there is no water, it's a solid, but it dissolves in water. So if you want to get back your pure water, you want to use simple distillation. If you want to separate two different liquids with different boiling points, then you use fractional distillation. For example, water and ethanol. Water boils at 100 degrees Celsius, ethanol at 78 degrees Celsius. So then the ethanol is the one that boils first, okay? Boil first, and then it will evaporate like that, and then condenses at the condenser, and then get transferred to the conical flask. So here in the conical flask, there will be ethanol. We go to the next topic, particulate nature of matter. The property of a gas that affect the rate at which it spreads. Alright, this one is called diffusion. The property is molecular mass. The higher the molecular mass, the slower the diffusion rate. So if they ask you something like this question, which gas has the fastest rate of diffusion? So you go to your periodic table and write down the molar mass of each of these substances So the fastest rate means the lightest substance, which in this case, hydrogen. The slowest will be sulfur dioxide. In which state does 1 dm cube of methane contain most particle? Now, most particle would be solid, because when a substance is solid, the particles are very close to each other, and that's why solid doesn't really get compressed that easily, if at all. All right. Gas looks like this. Gas particles are very far away apart. So solid has the most particles per unit volume. Let's take a look at atoms, elements, and compounds. This kind of question, which ion has the most shell that contain electrons? Most shell. So you go to the periodic table, and all of them are in their ionic state. All right. So what does it mean by ionic state? It means, like beryllium, it has 4 electrons. So the electron configuration is 2.2. So it's not stable. How does it become stable? It wants to adopt the electron configuration of the nearest noble gas, which is helium in this case. Okay, so it needs to lose 2 electrons, become beryllium 2+. So that means beryllium only occupies 1 electron shell. So you do that for each of these. Aluminium loses 3 electrons, so it occupies 2 electron shell, because from 2.8.3 it loses 3 electrons, so it ends with only 2 electron shells. Whereas nitrogen 2.5, it gains 3 electrons, it becomes 2.8. It still has only 2 electron shells, whereas sulfur gained 2 electron, and it has 3 electron shells. So the one with the most shell is sulfur. Now about this question. Table gives data about 4 substances, which one could be ionic compound. Now ionic compound is it consists of positive ion and negative ion. So there is a strong electrostatic force. So melting point must be high. Okay, so it could be C or D. Let's take a look later. Electrical conductivity in aqueous solution is good, because when the salt or the ionic compound is dissolved in water, you get free moving ions. All right. If you get either free moving ions or free moving electrons, you get electrical conductivity, either one of those two. All right. In this case, it's ionic compound, so free moving ions. Ionic ion. Right. So answer is D. Which substance contain covalent bond but also conduct electricity? There is only one substance in your syllabus that graphite conducts electricity. And why is that so? Because carbon has 4 valence electrons, but in graphite, carbon only bonds with 3 other atoms, making something that looks hexagonal like this. So there is 1 electron per carbon, right, that is not involved in covalent bonding. So these electrons can then freely move, and we call these delocalized, and it enables graphite to conduct electricity. Now isotopes are atoms of the same elements but different number of neutrons. So it is A, carbon and carbon. Here we have carbon 12, and here we have carbon 14. Now this one, diamond and graphite, we call this allotropes. Allotropes mean the same elements but different structure. All right. Diamond and graphite are both made of only carbon, but they have different structure. Which feature of a metal structure is responsible for conducting of electricity? This is what a metal structure look like. So you have the positive metal ions surrounded by delocalized electrons or free moving electrons. They enable electrical conductivity. All right. So for metals, it's the free moving electrons that causes it to conduct electricity. Which statement explains why isotopes of the same element have the same chemical properties? So chemical properties depend on the number of valence electrons, meaning the number of electrons on the outermost shell. All right, and that's why elements in the same group have similar properties because they have the same number of valence electrons. So here we say they have the same proton number because for neutral atoms, the number of proton equals the number of electrons. If the number of electrons is the same, then the valence electron must also be the same. A would be a better answer. Same electronic structure, meaning like this. For example, we deal with 2.8.2. This is the electronic configuration, right? Electronic structure. So the same number of valence electron. So this would be same electronic structure. Why copper is a good conductor of electricity? Again, copper is a metal, so it conducts electricity because the electrons move freely. So this is correct, right? But the copper ions, the metal ions, they do not move around. So B is the answer. So go back to our metal structure. The purple metal ions here, they do not move. If they moved, they would behave like a liquid, all right? But they don't move. That's why they are solid, like they stay in a fixed shape, right? They do not move. Only the delocalized electrons move, and that's why it's called delocalized. This topic hasn't been asked in paper 4, so it's likely to come out. Which pair of statements about diamond and graphite is correct? They are both pure carbon. This is correct. They are both macromolecules. Yes, they are giant. Diamond, graphite can both be used as electrodes. This is wrong. Only graphite can be used as electrode because graphite conducts electricity while diamond doesn't. Graphite also can be used as a lubricant. This is correct because you see these dotted lines, right? These are weak intermolecular forces. So because they are weak, it's very easy to slide the upper layer from the lower layer. So because they can slide easily, graphite is slippery. Diamond has covalent bonds. They both have covalent bonds. Graphite also. So C is incorrect. Diamond is hard and with high melting point. That is correct. Graphite is soft, again due to the weak intermolecular force, but still has high melting point. And the reason why graphite and diamond have very high melting point is because they are giant covalent structures. So they have numerous, like a lot of numbers of strong covalent bonds. Okay, covalent bonds are strong, and if you want to melt diamond, you have to break this bond, break this bond, break this bond, break hundreds of strong covalent bonds, and that's why you require a lot of energy to break all these bonds, and so high melting point. Same as graphite, you have to break all these CC covalent bonds. All right. Sodium nitrite contains nitrite ion. unstable decomposes into its elements. Sodium is group 1, so it's a +1 ion, and nitrite is group 5, is 3- ion. So if you want to combine them, you get Na3N. This is sodium nitrite, right? And how do I get that? This 3 go down, and this invisible 1 go down here. All right, you just swap the numbers around and you get Na3N. Or you can also think of it like this. 1 Na is plus, 1 N is 3 minus. So you need 3 Na plus to cancel the charge on 1 N. Okay, so it's Na3N. And then it decomposes upon heating to give you the individual elements. So the elements are sodium and nitrogen. Now we know that nitrogen is a diatomic molecule. So it's like oxygen. You always write down as O2. Now we have to balance this whole thing. 6 over there. And so it's B. Let's talk a bit about diatomic molecules. Right, so the 7 diatomic molecules are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. All these 7 elements are always diatomics. You write them down as H2, O2, N2, and so on. Calcium carbonate reacts with acid to produce carbon dioxide, and 10 grams of calcium carbonate is reacted with excess dilute hydrochloric acid. Which mass of carbon dioxide is produced? So here we have 10 gram, and we want to know the mass of carbon dioxide produced is how many gram. All right, so from the equation we can see that the ratio is 1:1 ratio, and this is molar ratio. 1 mole of calcium carbonate gives you 1 mole of carbon dioxide. So but you don't know the mole, you only know the gram. So you need to first convert the gram to mole. So mole of calcium carbonate is 10 gram divided by the molar mass, which is 100, is given here. The formula mass is 100, equals 0.1. So the mole of carbon dioxide is also the same because the ratio is 1:1 mole, right? So the mole of carbon dioxide is also 0.1. Now we convert it back to mass. So mass of carbon dioxide is mole, which is 0.1, times molar mass of carbon dioxide, which is 44, and you get 4.4 gram. Answer is C. Okay, I'm going to do this a different way. All right, so what I'm going to do is, instead of using molar ratio, I'm going to use mass ratio. All right, so 1 mole of calcium carbonate is 100 gram, right? I'm just following this 1 mole to 1 mole, but now I'm converting it to gram. So 100 gram is 1 mole of calcium carbonate, and 1 mole of carbon dioxide is 44 gram. How do I know? I know from the periodic table, the mass numbers, I'll just add them up together. All right, so 100 gram is to 44 gram. So if I have 10 gram, then that means how much carbon dioxide do I have? 4.4 gram. Just divide by 10, because here divide by 10, here also have to divide by 10. Complete combustion, when 1 mole of hydrocarbon is completely combusted. What volume? Now this one is important because it hasn't been asked in paper 4. So we have 1 is to 5 mole. 0.1 mole of pentane will produce 0.5 mole of carbon dioxide. How do I got 0.5? Because the ratio is 1 as to 5. So 1 pentane produce 5 carbon dioxide. 0.1 pentane produce 0.5 carbon dioxide. Okay. And then which volume? So we translate that to volume. Volume of carbon dioxide is mole of carbon dioxide times 24 dm cube per mole. So 0.5 times 24, and that is 12 dm cube, right? See, you can cancel the mole and you end up with dm cube. Which diagram shows the direction of movement of ions and electrons during electrolysis of molten sodium chloride? Now, cathode means electrode that attracts cation, and cation is, in this case, sodium is our cation. Chloride is negative ion, so it's called anion, so it's attracted to anode. Now what happens on the cathode and anode? On the anode we have chloride getting oxidized to chlorine, releasing 2 electrons. Whereas on cathode, we have sodium ion getting reduced to sodium metal. Alright, so the electron is produced on the anode because this here, electron is produced here. So the flow of electron will go from anode to cathode. This is the flow of the electron. And the flow of the ions, cation goes to cathode, anion goes to anode. So we go back here. Chloride goes to anode, that is correct. Sodium goes to cathode, that's correct. And electron is being released at the anode. So A is the answer. Molten sodium chloride and concentrated aqueous sodium chloride. So why am I asking a similar question? Because I want you to take note of the difference between molten and concentrated sodium chloride. All right, molten sodium chloride contains only 2 ions, sodium and chloride. So your products will be sodium atom or metal and chlorine gas. Okay, whereas concentrated aqueous sodium chloride contains 4 different ions, Na+, Cl-, H+, and OH-. The word concentrated means there is a lot of sodium chloride dissolved in the water. So there is more chance for chloride to be oxidized to chlorine rather than hydroxide to oxygen. Okay, so one of the products is chlorine gas. Now, how do we determine which one, sodium or hydrogen, gets reduced? Okay, potentially sodium can be reduced to sodium metal and hydrogen can be reduced to hydrogen gas. Now, which of these two products is more stable or less reactive? The one that's less reactive is hydrogen, right? Less reactive, or we also call it more stable. So this is the one that's going to be formed. So the product here is hydrogen gas forming at the cathode. Not sodium, but hydrogen gas. Right, so what are the products at the negative electrode or cathode? The products are, for molten, you have sodium because you don't have hydrogen at all. And then for concentrated aqueous solution, you get hydrogen. Answer is C. An object is electroplated with silver using aqueous silver salt as the electrolyte. Which row is correct? So let me draw. Let's say I have a spoon. Now here I have silver nitrate. What do I want? I want to coat the spoon with silver. So I need this electrode to be silver. And I need the silver ion to go and attach itself to the spoon. So how do I attract a positive ion? I attract it with a negative terminal. So here my terminal is negative and here positive, right? Negative, positive. Now what do I call the electrode that attracts cation? I call it the cathode. So we put the spoon on the cathode and we put silver bar on the anode. The object to be electroplated is the cathode because you want to attract cation. Silver ion is a cation and the other electrode must be silver. Answer is D. Winston Churchill wants to electroplate his false teeth with gold, and the teeth were coated with a thin layer of carbon. Now this thin layer of carbon is needed because teeth do not conduct electricity. So in order for electroplating to happen, you need to make it conduct. Now this carbon layer is actually graphite layer. Remember we talked about how graphite conducts electricity. Okay, so we want to attract gold onto the teeth. Gold is a positive ion because it's a metal, it's a positive ion. So you need the teeth to be negatively charged. All right, X is negatively charged, Y is positively charged. We call positive ion cation. So we call we make the teeth as our cathode. Cathodes are electrodes that attract cation. It's negatively charged. Okay, so terminal X is negative, and the carbon powder could be graphite because you need it to conduct electricity. Two gases that are formed when concentrated hydrochloric acid is electrolyzed using inert electrodes. Which row correctly describes the color of the gases? Okay, so concentrated hydrochloric acid. Again, we list down all the ions, H plus, Cl minus, and OH minus. All right, because we have water, so we have H plus and OH minus. We also have hydrochloric acid, so H plus and Cl minus. So out of the two anions, because it's competition between hydroxide and halides, we always choose the halide when the solution is concentrated. So in this case, halide becomes halogen, chloride becomes chlorine gas. And we have no competition for the cathode, so for the cation, so hydrogen is our product. Hydrogen gas. All right, so chlorine gas is pale yellow. It's formed on the anode. Why anode? Because chloride is an anion. It's formed on the anode. Whereas hydrogen is formed on the cathode because it's a cation and it's colorless. So colorless on the cathode and yellow-green on the anode. Answer is C. Oops. There is this type of question too, I just remembered. If, let's say, we have a setup that looks like this, or sometimes it's A, not V. Now this tells us that there is no battery used, okay? So it's not electrolysis. This must be voltaic cell. Yeah. So voltaic cell produces electrical energy, but electrolysis consumes electrical energy. So it needs battery, right? Voltaic cell is the battery. Now, if let's say we have a question like this. This is a dilute acid solution, and we have copper, right? Now, if they ask us how to increase the voltage, so how to increase the voltage is by making the difference of reactivity of the metals bigger. So, for example, we can replace zinc with magnesium, so it will be magnesium and copper. That will give you a higher voltage. Or you can also do zinc and then replace copper with something that is less reactive, like silver. That will also give you a bigger voltage. Okay, so if you take a look at the reactivity series, so if you have these two as your electrodes, the voltage is smaller than if you have magnesium and copper. Okay, this one gets bigger voltage. So it has to do with the difference in reactivity of the electrodes. Dissolving ammonium nitrate is endothermic. That means it takes in energy, so the temperature of the water decreases. And then it asks you what happens to the temperature when the solution is left to stand. So temperature of the solution first decreases, and then it will go back to the room temperature. So answer is B. It goes back to room temperature because there is no more reaction and there is no more energy getting absorbed. So it goes back to equilibrium. Which statement describes what happens when hydrogen and oxygen are used in fuel cell? So the reaction is hydrogen and oxygen produces water, and that's why fuel cell cars are clean cars, or we say hydrogen is clean energy because the product is water, and it produces electricity. So hydrogen is not burned, there is no burning in fuel cell, and hydrogen does not react with hydrocarbon. Electricity is generated directly. Electricity is used to produce water. No, electricity is not used, electricity is produced. So answer is A. This question, sorry, the quality is not so good because I took this from the unpublished paper of March 2022. Which row describes the changes that occur in an endothermic reaction? So endothermic, again, and energy is taken in from the surrounding, right? Taken in from the surrounding, and temperature decreases. The temperature that we measure is always the temperature of the surrounding. It's not the temperature of the system. Let's say these are the reacting particles, all right? We call these the system. Now, around it is water. We call the water the surrounding. Now, when the system or the reagents react, when these two react, the energy that is given out by the system, by the reaction, will be absorbed by the water. So if energy is given out, the reaction is called exothermic. Now we have our thermometer here, right? What are we measuring? Temperature of the system or temperature of the surrounding? It's the temperature of the surrounding, right? So temperature goes up. That's why exothermic temperature goes up. But if we have endothermic, is energy from the surrounding taken in by the system. So the energy of the water decreases. That's why the temperature of the water will also decrease. So in case of endothermic, temperature decreases. Fuels, heat energy is only produced by burning fuel. Let's leave it first. Hydrogen is used as fuel, although it's difficult to store. This is correct. Hydrogen is a gas at room temperature and pressure, so you need to compress it and then you need to put it in a tank, a secure one. So heat energy is not only produced by burning fuel. You can produce heat through radioisotope activities. Okay, radioactivity also produce a lot of heat without burning, right? Methane is a good fuel because it produces only water when burnt. This is wrong. Methane does not produce only water, it produces carbon dioxide as well. Actually, this should be hydrogen is a good fuel. And uranium is burnt. Now, uranium is a radioisotope. It is not burnt, it undergoes decay. And in decaying, it produces heat as well. Okay, so this is wrong. Answer is B. Which statement about endo-exothermic reaction is correct? This is about bond breaking and bond forming. This is an exothermic reaction. And this is an endothermic reaction. Activation energy can be the same for both endo and exo. It can be the same. It can be more or less. It doesn't matter, okay? Activation energy is not the determining factor here. But what do we know? We know that in exothermic reaction, this energy, the activation energy, is used to break the bonds. So this is bond breaking. Energy absorbed for bond breaking, whereas this part is the energy released during bond forming. The energy absorbed in bond breaking is less than the energy released during bond forming, whereas endo is the other way around. Endothermic reaction is where the energy absorbed for bond breaking is more than the energy released during bond forming. In an endothermic reaction, less energy is absorbed for bond breaking than is released in bond forming. This is wrong. It should be more energy. In endothermic reaction, the activation energy is always higher than in it doesn't matter. In an exothermic reaction, more energy is absorbed in bond breaking than is released in bond forming. No, this is actually less. And in exothermic reaction, the reactants are higher on energy level diagram than the... Yes, this is correct. D is correct. You see, the level here, this is the level of energy of the reagent or the reactants is higher than the level of energy of the product. So D is the answer. Next, chemical reaction. When zinc reacts with dilute sulfuric acid, a gas is released. This gas is hydrogen. Metal and acid produce hydrogen. What happens to the zinc and what is the gas released? So the reaction equation is zinc plus H2SO4 gives you zinc sulfate and hydrogen gas. So what happens here to the zinc? Zinc at first has an oxidation number of 0. It has no charge. And then after the reaction, it's now become zinc ion. It's a 2+ charge, okay? So zinc must have lost 2 electrons. Lose electron oxidation. Remember, Leo says GER, right? Lose electron oxidation, gain electron reduction. So zinc is oxidized. Answer is A. Which pair of metals will produce the highest voltage? Okay, this is what we talked about before. Voltaic cell in a simple cell. So we take a look at the metals and which combination give you the largest difference in reactivity. The most reactive metal of all these, copper, silver, magnesium, zinc, is magnesium. And the least reactive metal is silver, right? So the combination of magnesium and silver will produce the highest voltage. 4 electrolytes were electrolyzed using carbon electrode. Which set of data is correct? So copper sulfate will produce, this is how we do it again. Copper, list down the ions. Now if you have sulfate, this one will not go anywhere. Sulfate nitrate, it stays in the solution, okay? They don't undergo reaction. But here, hydroxide will become oxygen on the anode. Why anode? Because hydroxide is an anion, it's a negative ion, so it goes to anode. And then between copper and hydrogen, we have to think about the products. Which one is more stable or less reactive? Is copper. Copper is less reactive than hydrogen. So copper is the one that is produced, and this time on the cathode, because copper 2+ is a cation. Copper cathode and oxygen anode. This is correct. How about B? B is aqueous, so you have Na+, Cl-, H+, OH-, okay? Depending on its concentration. If it's concentrated, you will get chlorine on the anode. If it's dilute, you get oxygen. So let's pretend this is correct. This is concentrated, you get chlorine. Now between sodium and hydrogen, which one will give you a more stable or less reactive product? Is hydrogen, because hydrogen is less reactive than sodium metal. Sodium metal is group 1 metal, very reactive. So it will not stay as metal for long, okay? So it will not form. So answer should be chlorine and hydrogen here. And here we have sodium and hydride. Sodium is a positive ion. It's a cation, so sodium must be formed on the cathode, not on the anode. So these two must swap. All right. It's liquid, molten. There is no water. There is no competition. Oh, which one gives you a less reactive product? There is no such competition. So it's the products are sodium and hydrogen. That's correct. But they appear at the wrong electrode. All right. Next, this again molten, and again lead is positively charged. It's called cation, so it's produced at on the cathode, so this should be swapped. If a strip of magnesium is dropped into excess hydrochloric acid, exothermic reaction occurs. The rate of this reaction increases for the first few seconds because it's exothermic. So the solution becomes hotter, and higher temperature means higher kinetic energy, so more frequent collision, and so the rate of reaction increases. Adding substance X to a reaction mixture changes the reaction pathway. So X must be a catalyst. Which change is likely to be observed when X is added to the reaction mixture? Is not becoming more or less exothermic. It doesn't matter. It will still be the same exothermic or same endothermic, because you see the energy level difference between the reactant and the product, it's still the same. So delta H or enthalpy change is the same, so it's equally exothermic even with catalyst, right? The speed of reaction though will increase. So D is the answer. Which process does not involve either oxidation or reduction? Now, this is how you do it in a fast way, okay? If you have something that is element turning to compound or ion and vice versa, this must be redox. If it's compound to compound, it may be redox, but you have to check the oxidation numbers and stuff. But for this one, you see here, formation of zinc, which is an element, zinc is an element, to form what? To form zinc blende, which is a compound. So this must be redox. We want something that is not redox. Sulfuric acid is a compound. Sulfur is an element. So it must be redox. Nitrogen monoxide from ammonia. Now this is a compound. This is also a compound, so we will check later. How about ammonium sulfate from ammonia and sulfuric acid? This is compound and this is compound. Compound, and this is also compound. So let's write down the reaction equations here. Ammonia reacting with sulfuric acid gives you ammonium sulfate. And the second one, how do we define redox? We can define it in terms of transfer of hydrogen, transfer of oxygen, right? Transfer of electron, or changes in oxidation number. Now in this case, nitrogen in ammonia doesn't have oxygen, it has 3 hydrogen. And then after the reaction, it gains 1 oxygen and loses 3 hydrogen, right? So this definitely redox. The oxidation number of hydrogen is always +1. I don't know if you guys study oxidation number, but 3 hydrogen makes +3. So nitrogen must be -3. Okay. Now if you go to the other side, hydrogen is still +1 and NH4 plus. So if hydrogen is +1, here we have a total of +4, and here we need a -3 to get a total of +1. How do I know the total is +1, not 0? Because the charge of the ion here is +1. Okay. So the oxidation number of nitrogen is -3. So there is no difference. No difference. Sulfate stays as sulfate. No difference. Okay. So A is not a redox reaction. How does increasing the concentration affect the reacting particles in a chemical reaction? It's increasing the collision rate. It collides more often because there are more number of particles per unit volume. Okay, so these are correct. And increases the proportion of particles with the activation energy. This only happens with increasing temperature. So it doesn't happen when you change the concentration. So answer is A. The diagram shows the reaction between zinc oxide and hydrochloric acid. Zinc oxide is an amphoteric oxide. It means it can react with either an alkali or an acid. Right. Look at the temperature. Temperature rises, so this must be exothermic, and the pH goes from 1 to 7, so it must be neutralization. Answer is The apparatus shown is used to measure the speed of reaction. Which equation represent a reaction where speed can be measured using this? So it needs to be a reaction that involves gas. So here we have hydrogen gas, and yeah, that's all. So A is the answer. Element vanadium forms several oxides which change in is oxidation taking place. Let's see A. O is -2 oxidation state because the oxide is O2 minus, right? And then we have 2 oxygen. So in total we have 4 minus. So vanadium must be +4. We want to make the total oxidation number 0. O is -2 and V is +3. This is how you do it quickly. 3, the number goes up here, and then 2 goes up here. Okay, so you swap the numbers. Vanadium goes from +4 to +3, so that must be a reduction. Vanadium is reduced, right? Not oxidized. So A is not your answer. And then here O is -2 and V is +5. Again, I just swap the numbers, and it becomes -2 and +4. Okay, so vanadium is again reduced because it goes from +5 to +4. Now swap the number again, -2 and +3, and here we have -2, so V must be +2. So V goes from +3 to +2 is again reduced. Here +3 -2 becomes -2 here +5. Now this time vanadium oxidation number goes from +3 to +5. It goes up. So this is oxidation. Answer is D. Aqueous solution of a sulfate is made from a solid hydroxide by the reaction of this. For which hydroxide would the method not work? You want to make aqueous solution of a sulfate. So the sulfate must be aqueous, alright? If you go with barium hydroxide, barium sulfate is produced, right? Remember our solubility rule, barium sulfate is insoluble. Now copper sulfate is soluble, so it can be made using this method. Iron 2 sulfate is also soluble. Magnesium sulfate is also soluble. So only barium hydroxide is not gonna work, okay, because you need the product to be aqueous. Methyl orange is added to acid and to aqueous sodium hydroxide. Methyl orange is yellow above pH 4 and red below pH 4, and the transition between red and yellow is orange at pH around 4. So color in dilute hydrochloric acid would be red, aqueous sodium hydroxide would be yellow. Answer is B. Next, information about some silver compounds. Look at the salt. If the salt is insoluble, you need aqueous and aqueous reagents. So this will work. If the salt is aqueous, you need excess insoluble base, alright, with acid. So this will work. And this also works. This is aqueous product. You want to make an aqueous product, so you need excess insoluble base, right, and the acid. This will work. Now here, see, if what did we say for the first one just now? If you want a solid product, you have to start with 2 solutions. You cannot start with another solid. So this will not work. And the reason why you cannot start with another solid is this. if we have silver and this is insoluble, and then we react it with acid, the reaction will happen on the surface here. So this surface will form silver chloride, which is a solid. So the acid will be cut off from the remaining silver, okay, because there is a layer of insoluble product. So the reaction will stop quickly. Periodic table, this is not going to show up a lot because they already asked about this, but let's try only one. 5 elements with different proton numbers. What are the proton numbers of the 3 elements that form oxides? So these two gases in the noble gas, they will not form oxide. The rest will. So 3 of them will. We don't get these oxides, but we get 12, 14, and 16. Aluminium is extracted from purified bauxite, but iron is extracted from hematite with reduction of coke. So why iron is not extracted by electrolysis? The method that is chosen must be the most economical, okay? So if carbon is more reactive than iron, then you can simply just react the hematite or iron ore with carbon, and then carbon will displace iron and you get carbon dioxide and iron metal. All right, so will it work with electrolysis? It will work, but it's much more expensive because you need to melt iron 3 oxide. Okay, so the answer is reduction with coke is cheaper than electrolysis. Old steel drum corrode quickly in damp atmosphere, but aluminum cans do not. And why is that? Aluminum is group 3. It should be quite reactive, but it doesn't seem to react that much because it's protected by its oxide layer, which is aluminum oxide. Cesium is a metal that's more reactive than aluminium, so the production would be electrolyzing molten cesium chloride. If you electrolyze aqueous cesium chloride, you will get hydrogen and oxygen or chlorine, depending on if it's concentrated, you get chlorine, right? But you get hydrogen for sure and never get cesium because hydrogen is more stable. Which word equation represent a reaction that occurs? So you have to take a look at the elements. If the elements are more reactive than the metals in the compound, then it can displace. All right, so this is less reactive, this is less reactive, copper is less reactive, but carbon is more reactive than iron, so this reaction will happen. Extraction of aluminum, again aluminum is formed at the cathode, all right, because aluminum ion is a positive ion, so it's a cation, it's formed on the cathode. Hematite is iron 3 oxide, not aluminum oxide. Molten cryolite is used to reduce, not raise, but reduce the melting point of aluminum oxide. Oxygen gains electron at the anode. Actually, oxygen, it's not oxygen, it's oxide ions loses electrons because oxide ion undergo oxidation, okay, lose electron. So answer here is A. In Haber process, which factor increases both speed and amount? So the reaction is exothermic, is favored by low temperature, cannot be increasing temperature. because increasing temperature will drive the equilibrium to the left. Okay, it favors the endothermic direction. Adding catalyst will increase the speed, but it does not do anything about the amount of ammonia, so cannot be catalyst. Decreasing pressure will reduce the speed, so cannot be that. Answer is C, and it's because this is a gaseous reaction. So increasing pressure means you have to make, let's say we have this chamber. If you want to increase the pressure, you want to reduce the volume. If you reduce the volume, you have higher, like sort of higher concentration, right? More frequent collision. So speed of reaction increases. And also look at this side. This side we have in total 4 moles of gas, and this side 2 mole of gas. So if you reduce the volume or increase pressure, it favors the side with less gaseous moles, less mole of gas. Okay, which means equilibrium shifts to the right, producing more ammonia. So answer is C. Reaction production of ammonia is reversible. The equilibrium is established. Which statement describes equilibrium? So both forward and reverse reaction have the same rate. This is correct. And because of that, the concentration of both reagents and products stays constant. Okay, I'm not saying that the concentration of both reaction and products are the same. They're not the same concentration, but the concentrations stay constant. They don't change anymore. The source of nitrogen is air in Haber process, and the source of hydrogen is cracking of hydrocarbons. And temperature is 450, pressure is 200. So answer is C. Contact process. The catalyst used is vanadium 5 oxide for this. By the way, the catalyst used in Haber process is iron. Lime is CaO. So it's made by heating calcium carbonate, because calcium carbonate decompose to give you carbon dioxide and lime, CaO. Alright. Lime is used to desulfurize flue gases. This is correct. What does it mean? It means that lime is a basic oxide. It will neutralize sulfur dioxide gases, which are acidic, in the in industry there is chimney, and then you can see the pollution coming out of the chimney. That's called flue gases. All right, so lime can neutralize acidic gases. And then lime is also used to treat acidic soil, not alkaline soil. Chemical name is calcium oxide. So 1 and 4, 2 is also correct. Yeah. So B is the answer. Air and water. Photosynthesis is where carbon dioxide gives you carbon compounds. Carbon dioxide is made into glucose. Okay. So A is the answer. Which following gases cannot be removed from exhaust gas of a petrol-powered car by catalytic converter? So catalytic converter, we have carbon monoxide, nitrogen monoxide, okay, and the reaction would give you carbon dioxide and nitrogen. Now another one reaction is the unburnt hydrocarbons, which are carcinogens, will undergo oxidation in the presence of catalyst, not burning, but this is catalyst, to produce carbon dioxide and water. Okay, so the waste gas from catalytic converters are carbon dioxide and nitrogen and water. Well, nitrogen and water are not really considered as a pollutant. All right. So answer here is carbon dioxide cannot be removed. Nitrates used on farmland can cause pollution. Why do nitrates pollute rivers? So if you have a field and then you put nitrates on the field, right? This is the fertilizer. When it rains, what happens to the nitrate fertilizer? It will run down into the river, okay? And then the river becomes highly nutritious. The water is it contains a lot of nutrition, so it grows a lot of algae.
When they die, they decompose, and decomposition requires aerobic bacterial activity, and it results in decreased dissolved oxygen level.
So then the fish will die because they run out of dissolved oxygen in the water, and this is called the eutrophication. So what caused this pollution is because nitrates are very soluble in water. Carbon dioxide and methane. Methane is formed when vegetation decomposes. Both are greenhouse gases present in unpolluted air. This carbon dioxide is present in unpolluted air, but methane doesn't. Produced during respiration, carbon dioxide is produced, methane is not. So B is the answer. Some uses of water. Which uses is it necessary to chlorinate? Means to kill bacteria. So it's for drinking, swimming pool 1 and 3. Which is a use of oxygen? It's for making steel, and oxygen is used to make steel because of this. You know the blast furnace, right? The molten iron that is produced here contains a lot of carbon, okay? So if the carbon content is too much, the steel becomes
Brittle.
So that's why you want to get rid of carbon by how? By blasting it with hot air or hot oxygen. All right, so carbon now reacts with oxygen to produce carbon dioxide, and carbon dioxide will be gone, right? So that is to make steel. Fertilizers contain 3 main elements, and you have to find N, P, and K. So this C is the answer. A new planet has been discovered, and the composition of the atmosphere is given here. Which gases are present in the atmosphere of the planet is higher percentage than on Earth. Okay, so on Earth, carbon is around 0.4%, nitrogen is 78, and oxygen is 21. So which ones are higher? Is carbon dioxide and oxygen. A is the answer. All right, last topic, organic chem. Structures of acid and alcohol are shown. Which pairing of names correctly identify? Okay, so when carboxylic acid and alcohol reacts, what happens is this bond breaks to create an ester, and the name starts with the name of the alcohol, which is, because we have 4 carbons, this is called butanol, and the acid is propanoic acid. If they ask, the name of the ester is butyl propanoate. Okay, start with the alcohol name first. Now acid is propanoic acid and alcohol is butanol. D is the answer. Which physical property of the alkane does not increase as relative molecular mass increases? As you go down the homologous series, right, the chain becomes longer, molecular mass increases, so boiling point must increase. So that's not the answer. Flammability actually decreases because the bigger the molecule, the less likely it will evaporate. Okay, so it's not as flammable as gas. So yeah, melting point increases, so this is not the case. Viscosity is also increasing. Viscosity is thickness. It's like honey. Honey is more viscous than water, right? It's thicker than water. Flammability actually decreases. Polymer X was hydrolyzed and two products were formed like this. What can be deduced from X? So because the monomer of X are dicarboxylic acid and diamine, it's not formed because of alkene, right? So it must be a condensation polymer. And actually, if you break these bonds and one of the H's bonds here, you will get amide linkage. So so X is actually a polyamide, right? Like in nylon. It's not in terylene. Terylene is polyester. Nylon is polyamide. So A is correct. This is not starch. Starch looks like this. Starch is made of simple sugar. Okay, so the link is just oxygen like that in the middle of carbon chain. And it's not addition polymer because addition polymer requires C double bond C, but here the important parts are dicarboxylic acid and diamine. So it's condensation. Which polymer has the empirical formula of CH? So you just find out like the empirical formula of each of these. C2H4, so that is CH2. This is the empirical formula, right? And here we have 1, 2, 3. C3H6, that's not CH, that's CH2. Now we have 1, 2, 3, 4, H8. So that's also CH2. And here we have C8H8. Now this is CH. So answer is D. And in the polymerization of ethene to form polyethylene, there is change in boiling point because ethene is small molecule, right? So boiling point is low. Polymer is high. Density changes because ethene is a gas. Polyethylene, due to the high boiling point, it's not a gas, it's a solid. Polyethylene is plastic, right? It's solid. So density actually changes. Mass doesn't change because the total mass of ethene will be the total mass of polyethylene, right? Mass doesn't change. The total mass doesn't change, but the molecular formula changes. Ethene is C2H4. Polyethylene is maybe tens of C's or even hundreds of C's. Okay, so molecular formula definitely changes. Answer is C. Next, structure of ester. What are the names of carboxylic acid and the alcohol? So we have to find the link, ester link, and then we split it to 2. And on this side, we have the alcohol side, and this is called propanol. And on this side, the one with the double bond, right, is the carboxylic acid. It's called ethanoic acid. So ethanoic acid and propanol. Answer is B. Which structure is correctly named? Now here we have 3 carbons, so it's not ethanoic acid, it should be propanoic acid. Here we have C single bond C, so it should be ethane, not ethene. Okay, this should be propanoic acid. And C is correct. 2 carbons means eth, and this alcohol is all ethanol, and this is propene, not propane. So C is the answer. Carboxylic acids were made by the oxidation of alcohol. Which carboxylic acid is produced by this? Now, the name is ethanol, so the carboxylic acid is ethanoic. Which statements about ethanol are correct? Ethanol is used as solvent. It can dissolve polar and non-polar substances, so it's a very good solvent. Ethanol can be directly made from ethane. This is wrong. It can be made from ethene reacting with steam. All right, and this is a review. And the conditions are 300 degrees Celsius, the presence of acid, usually phosphoric acid, and 60 to 70 atm of pressure. Ethanol is a covalent compound, so 1 and 3 are correct. Nylon is a polyamide. It's made of dicarboxylic acid and diamine. Right? So this cannot be because this is ester linkage. This is no linkage. This is the correct linkage, right? But we need this repeatedly. That's why it's called polyamide. This one is a structure of nylon. Answer. Now, what's the difference between nylon and protein? Both of them have amide linkage, but this is the difference. So protein is made of an amino acid, right? Amino acid, one molecule of amino acid contains 2 functional groups, carboxylic acid and amine. So the simplified structure of protein, it looks like this. N, H, and then here we have C double bond O, N, H, like that. So we have C double bond O and H, C double bond O and H, like that, alternating. But in nylon, it's C double bond O and H, C double bond O, C double bond O, and H, like that. All right. So you should know that if it's alternating, you're dealing with protein. If it's NH, CO, NH, you're dealing with nylon. Coal is a fossil fuel. Which gas is not formed when coal burns? Of course, carbon dioxide will form, carbon monoxide will form. Methane is not formed. Methane is CH4. It's not formed when coal is burnt. Sulfur dioxide is formed because in any fossil fuel, the main impurity is sulfur. Which functional groups are present? So we have alkene here, we have carboxylic acid only. So alkene, carboxylic acid, and we do not have alcohol. C is the answer. Right, this is one entity. You don't break the OH. It's COOH, carboxylic acid. Which fraction of the fractional distillation of petroleum does not match its use? Let's do from D first. Refinery gas for heating and cooking. This is correct. It's also one of the gases that you put in those small bottles and then you go camping for cooking, right? Naphtha is not for making roads. Naphtha is for making chemicals, also sometimes used in medicines, okay? And kerosene is for jet fuel. Fuel oil is for domestic heating, for heater during winter. Okay, some heaters use fuel oil. So answer is C. The diagram shows apparatus used to separate petroleum into 4 fractions. Which fraction contains the smallest hydrocarbon fuel? It's the one with the lowest boiling point. Okay, smallest hydrocarbon molecule means lowest boiling point. So it's A. When a long chain hydrocarbon is cracked, the following products are formed. Which product will decolorize bromine water? This is the alkene or alkyne. Okay, so it's unsaturated. So we have to find out if it's CnH2n plus 2, which is alkane, which will not decolorize, or CnH2n will decolorize. Okay, so not this, 2 and 3 will decolorize. B is the answer. PVA is a polymer. The monomer has this structure. To which homologous series does this belong? So it belongs to alcohol because of the OH, and it belongs to alkene. So A is the answer. Okay, last one. Which equation represents incomplete combustion? Incomplete combustion produces carbon dioxide and water. Carbon dioxide and water. So answer is C. Okay guys, thank you so much for staying until the end of this video. I wish you all the best for your exam.